Athletes, what we're going to look at here is something known as inductive reasoning. We're going to look at two types of reasoning as we go through this unit, inductive and deductive. But we'll start with inductive, and we're going to talk about making conjectures. All right, what you're going to find here this year, kind of going, what the heck? Sounds like English class, right? Yeah, in this unit, friends, I'm definitely going to need you to know some definitions. So this unit's all about reasoning, and really reasoning or mathematics in general is all about just finding patterns and making plans, making a guess, a good assumption for what's going to follow. And that's what we're going to do today. So we're going to look at inductive reasoning and conjecture. So an inductive reasoning is when we see a pattern or we have a specific set of examples, and we're going to try to come to a conclusion as to what the pattern is. Our conclusion or proposition, eh, it's just an educated guess. Okay, we don't have no real proof, but it's a good educated guess. Okay, so we're going to talk about the difference between a good educated guess, a conjecture, and a full proof as we go through this unit. Okay, now a couple other things we'll talk about as we go through this unit are validity. So does our argument have any sense to it? Does it make any sense? Am I telling you a lie and telling you to believe it? Okay, so we'll talk about validity, and counterexample is, okay, well, there's clearly something wrong, and I'm going to give you an example that proves that you're wrong, right? So these are kind of the things that we're going to work through. This is going to feel very different than maybe many of the other math classes and units you've done before. Okay, I kind of like it because to me, it's like puzzles. Okay, so here we go. Here is a good example. What are the next numbers in the following sequence? Well, what I recognize here is that these are actually perfect squares. That's 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. So what I'm guessing, my conjecture would be, is the next few terms would be 6 squared, 7 squared, 8 squared. So my conjecture is that this sequence is made up of perfect squares. Now, how I arrived at that was called inductive reasoning. I see an example and I make a pattern out of it, and I think that this is what is going to happen. So this is called inductive reasoning. I cannot prove for certain that I have done this correctly. Okay, that'll be called deductive. That's it for now. Okay, so let's keep going here. Let's try a couple more examples. So consider the following pattern of triangles. Okay, so what I want you to do right now is I'm going to pause the video. I want you to think about right now, look at these triangles that I've got here for you, and I want you to fill in the table, and then I want you to try to make a conjecture. So hit pause on the video, and I want you to try that for a couple minutes. I'll see you soon. Hey friends, you're back. And so what I asked you to do was to fill in this table. So I'm going to count the number of small triangles I see. So it goes 1, then it goes 4. The next one I see 5 in that row, 3 in that row, 1 in that row. So I see 8, that's 9. So what I would like to then do is say to myself, what if this pattern continues? And I suppose I could draw this thing out and start to see. So I need to start to figure out a pattern. So in the bottom, in the first figure, there's 1 triangle. Figure 2, there's 2 triangles. Figure 3, there's 3 triangles. So in figure 4, then it stands to reason inductively. Hey, sounded really nerdy there. There's going to be 4 triangles, right? On the bottom like that. And then I complete it. And now it's going to go, that looks like 7. And then the rest would follow from the picture that we had before, like that, and we would then have 5, and you keep going, you can see the pattern, 3, then 1. So our next one then would be 16. So if I had to make a conjecture as to what's going to happen each time, I see a couple of different patterns here. But again, 1, 4, 9, 16. This sure sounds like perfect squares to me. The other thing I notice is, like I said, in the base, I had 1 triangle, 3 triangles, 5 triangles, then 7 triangles. So I'm guessing the next base, I'm going to add 9. And 16 plus 9 is 25. And the one after that, I'm going to make a conjecture that I'm going to add another 11. So my conjecture is that the number of small triangles for each figure will end up being a perfect square. Now, again, I don't know for certain that I am right. Maybe the pattern falls apart at figure number 100. I don't know. I would not bet my house on this, but it's a good conjecture using inductive reasoning. Okay. And sometimes we just got to get used to writing these sentences again that you're trying to explain to someone what you're thinking. Okay. Now let's try a couple more of these ones. Inductive reasoning. So use inductive reasoning. So that means I want to use an example, right? That's what that means to me. Give me an example to make a conjecture about the product of 2 odd integers. Okay, so I'm just going to make up an example, 2 odd integers. And it says the product, so I'm going to multiply them together. I get 15. Okay, let's do another example. What if I did 7 times 9? That's 63. What if I did 1 times 11? I get 11. So I do a few examples myself, and then I say to myself, make a conjecture about the product of 2 odd integers. Well, what I'm noticing is the product from my 3 examples looks like the product will be odd. So my conjecture would be the product of 2 odd integers will be odd. Okay. Again, I haven't proved it. It's just a good educated guess. That's what a conjecture is. Okay. In another lesson, we're going to do deductive reasoning, and we will prove if it's true forever and ever and ever, and if I would bet my house on it. Okay. Use inductive reasoning to make a conjecture about the product of 2 consecutive integers. Okay, I need you to know that word. Consecutive means we go in a row. So the product of 2 consecutive integers. Well, here's a bunch of integers. Dot, dot, dot. -3, -2, -1, 0, 1, 2, 3, dot, dot, dot. So the product of 2 consecutive integers. So I could take any 2 integers I want. Those 2 are consecutive. And if I multiply them together, I get 6. Let's do another 2. This pair. -3 times -2, I get 6. Right? So if I was to just make a conjecture right now, based on the 2 examples I made, I would maybe say something like, oh, I'm always going to get 6. Well, let's make a few more examples. Right? Well, what do we get here? -2 times -1 is +2. Okay, well, I don't get 6 anymore. Try one more. What's 0 times 1? I get 0. Okay, what's my conjecture then? What am I noticing from my pattern? Well, what I'm noticing from my pattern is the product of 2 consecutive integers is even. And yes, friends, 0 is even. Okay, because it's divisible by 2. 0 is even. That's a big fact I need you to know for 30-2. So my conjecture would be the product of 2 consecutive integers is even. And again, that's induction. I have not proved it. We will use deduction in another lesson to prove for certain that I am correct, or my conjecture is correct. So there it is, friends. Like I said, it feels different than the math you're used to doing, but this is reasoning, and math is all about reasoning. I'll see you another time.